How's it going, guys? So today we're going to be talking about the least common multiple. So before we begin to actually show you some examples of least common multiple, we're going to define them. So a multiple is, let's use orange here, the product of one number multiplied by any other number. Okay, so let's say multiples of, so we're talking about like example, would be like 2 times 1 equals 2, and 2 is our multiple, okay, of 2 times 1. And then I take that same number, 2 times like 2, and then 4 is a multiple of 2. Okay? Alright, so next thing we need to know is, well, what is the least common multiple? Well, when we think of least, we think of smallest. And common means the same, so it's the smallest common or the same multiple of a couple of numbers. So let's write that down. So least common multiple is the smallest pair of multiples between two numbers. Now, when I say pair, you can actually have least common multiple with more than 2 numbers, but for now we're just going to be using 2 numbers. Okay? Alright, so the next one we're going to do is we're actually going to show you some examples of how this works. So our first example, I'm going to show you 3 methods on how to solve this problem. Okay, so the first way, I'm going to call it method 1, number 1. And method number 1 is the list. So the list. So here's how the list works. So I'm going to take 2 numbers. So let's pick, let's do 12, and we'll also do, let's try 8 as well. Okay, so I'm going to try to find the LCM, or the least common multiple, for 12 and the number 8. So the list, all I'm going to be doing is listing multiples. So what I like to do when I list the multiples is I just like to put what I'm multiplying them by. So times 1, times 2, times 3, times 4, times 5, and times 6. And we can even go times 7, why not? Alright, so underneath each little multiplier here, by times 1 or times 2 or times 3, we're going to write our product. So 12 times 1 is obviously 12, and then 12 times 2 is 24, and 36, and 48, and then the next one is 60, and 72, and then we also now have 84 for 12. And then for 8, so we're going to do the same thing. So 8 times 1 is 8, and 8 times 2 is 16, 8 times 3 is 24, 8 times 4 is going to be 32, 8 times 5 is going to be 40, and then 48, and then finally we are going to have 56. So what the least common multiple is, remember, it's the smallest pair of multiples. So let's find all the ones that they have in common. So let's find all the common ones first. So we have, over here we have 24 is in common with 24. I'm going over here, oh look, I have 48 and 48. And I bet if I kept going I could find a few more. But for the sake of showing you the example, so the least common one, the smallest one for 12 and 8 is, so the LCM for 12 and 8 is 24. Okay. Now, now that we know that it's 24, I'm going to show you a different method. So this method is method number 2, and I'll write this right here. And method number 2 is, I like to call it Optimus prime factorization. And so with Optimus prime factorization, so what we're going to do is we're going to prime factor the couple numbers. We're going to prime factor 12 and we're going to prime factor 8. And we're going to do something with those factors. And hopefully we'll be able to solve for LCM just by using prime factors. So let's start with 12 right here. So I'm going to do 12, and that is 12 is the same thing as 3, another one, times 2 times 2 when I prime factor it down. And then also with 8, when I prime factor 8, it's going to be 2 times 2 times 2. Now, here's how this method works. So if I have, so what I like to do with these prime factors is I'll do 12 in orange and I'll do 8 in yellow, so we can really separate them. So what I'll do is I'll do my 8 right up on top right here. So 8 is the same thing as 2 times 2 times 2, and 12 is the same thing as, well, 3 times 2 times 2. Now we need to find 24. So we already know that our LCM is 24 because we use the list method. But with the Optimus prime factorization method, we need to do a couple things. So the first thing I'm going to do is I'm going to circle the ones that are matching. So I'm going to circle these ones, this pair of 2's and this pair of 2's. Now this pair of 2's becomes 1, 2. And then this pair of 2's becomes 1, 2. And then I also have an extra 2 and an extra 3. And so I write those down right here, so an extra 2 and an extra 3. And then what I do with these is I multiply these numbers together. So I multiply 2 times 3 times 2 times 2. So 2 times 3 is 6. And then 6 times 2 is 12. And 12 times 2, well, hey, guess what? I get to 24 again. All right, so now the next method, I might run out of room, but we'll see. So I'm going to use, this one is method number 3. And method number 3, I like, some people call it the upside down birthday cake. And I actually like this method quite a bit. So we start with our numbers, 12 and 8. And so what I do with 12 and 8 is I just put a little box like this around them, 12 and 8. And so with 12 and 8, now what I'm going to do is I'm going to pull out a number, a factor that I know that they have in common. So, well, they're both even, so I'm going to pull out a 2. And so I'm going to write the number 2 right here. And so when I pull out a 2, so I'm kind of using the distributive property here, and so when I pull out a 2, this is going to now turn into a 6, and this is going to be a 4. And I can still pull out another number. So I pulled out a 2, so 12 divided by 2 is 6, and 8 divided by 2 is 4. And I can still pull out another number here, so I can still pull out another 2. So let's do that. So I'm going to pull out a 2 right here. And this 6 now becomes a 3, and 4 divided by 2 is 2. Well, now I can't pull out any common factors between 3 and 2, so I just rewrite them down here on the bottom, 3 and 2. Now, these numbers might look very familiar because they're the exact same numbers as up above. 1, 2, 1, 3, another 2, and another 2. So I have a 2, a 2, a 3, and a 2. So all I do with method the upside down birthday cake is I take the numbers that I factored out and my leftover numbers, 3 and a 2, and then I multiply them together. So 2, this 2, and then this 2 right here, times a 3 times a 2. And 2 times 2 is 4, and 4 times 3 is 12, and 12 times 2, hey, guess what? I have 24, and 24 is my LCM. So these are the three methods that you can use. So you can use the list method. If you know all of the multiples, if you know your multiplication tables pretty well, you can use the list method and find the smallest one that they have in common. If you like prime factorization and you can remember to count the pairs and the matches as one of those numbers, so this one's, I have a 2, so this one counts as a 2, and there's a couple of 2's here, and that one counts as a 2. And then down, or you can use the birthday cake method. You can start using the distributive property to pull out common factors. And so in the end, we're left with just prime factors. All right, my phone's ringing, so I gotta go. See ya.